Whoa, sass. All right, so reviewing what we did. Oh, here's the other thing, Connor. I moved this screen really quickly when we were doing this, and it was kind of off the screen so that we could enlarge all of this. So it was probably not very much in your face that we did 831.
If I had just actually watched the video, but I just quickly glanced.
So with needle and thread. So is an acronym in trigonometry. So when I have to repeat so a bunch of times, I start to try to say other things. So if we want to fill in our plan book together, you guys don't use plan books, do you? All right. Well, this is recording. So here's our plan for the week. 832 is today. 841, which to give you some, what are they talking about? 841's lesson is a special ratio.
Special.
Yeah. Who's to say what they're doing there? And then this is the rest of the chapter. That's it.
Don't change it.
So then a closure. Now here's the weird thing. Who is able to tell me what is potentially weird about this week?
I don't think we have math on Friday.
Okay, well that was going to be my question too, because I felt like it'd been a while since we didn't have math.
That's
One of you go check the calendar in the hallway, see if it tells us.
Mr. Matt said we don't have
On the
math
18th.
at some point.
This weekend is not the 18th. I don't know, did they change it yet? Alright, well I'll check with an 8th grade teacher. Oh, Connor, my bad. My stuff's in your way. This is math sense.
Yeah, I was going to ask about that, but I was like, wait, I don't have to write stuff down.
It's like all my extras and stuff.
That was 3 years ago that I did that.
I know, it feels like forever, right? Alright, so today we should be able to get through the lesson pretty quickly. Not as quick as Friday, because there are a couple application problems here that might make us actually think a little bit.
What?
Yeah, like conversions between metric and American when we're already discussing area. Those things get a little weird.
I love metric.
Oh, didn't we do some
But
last year?
parts of this that we can get through quickly that I'm okay with you guys still walking around.
Those two are walking.
Yeah, I know. I've started to notice it takes a lot to get you guys to actually sit.
I'm sitting.
Not you. So, this is probably one of the more simple questions to answer that we don't need to write anything down for. If Alice is looking to enlarge a picture of her team, and the original picture that the team photographer took is in a 4:5 ratio. Now, you guys are smarter than we were when we were your age, and you understand, screen ratios. Do you know any examples where, we use different ratios for, a picture or a video versus something else? Huh? Yeah, so my YouTube videos are a weird ratio because I just set it to capture my screen. It's not a standard set ratio. See the red and white dotted line? So it doesn't quite encapsulate just what's showing on my screen, right? That would stop right here at the toolbar. And it doesn't quite, really what I should do is slide this down a tiny bit so you can see the date on my videos. I don't know why. I don't necessarily have it like that, except sometimes these things pop up.
It says it was posted that day.
Yeah, that, and I always date my videos. So, Jake, why did you circle what you circled?
Because that's the correct ratio and none of the other ones factor in nicely.
So they would either stretch the picture in an odd manner, or somebody would get cut off, right?
That's fine.
If you didn't zoom to fit, right? So okay, 8:10 would be the correct if these are the choices, right, at the shop. But then the cost to print a 4:5 is 45 cents. So assuming the cost is by per square inch, how can we figure out the square inch cost of printing?
You square it. It's gonna be
Square it?
no.
Guys, be careful when you like try to answer as quick as possible.
It's times 4.
Kind of square.
It's times 4. So
Square.
180.
2. And then you multiply it by that.
Yeah.
So-
same thing.
I think you're rushing to answer the question I haven't asked yet. The question I did just ask is how could we calculate the price of this printing? Not of the new picture, but the unit price of this Photoshop. So what do we know about the,
45 divided by 20.
what is it?
0.45 divided by 20.
So 45 cents divided by our 20 square inches, right? So what is that?
Not a fun number. Wait, it's like 2.4? I want to say?
0.0225.
Yeah. That's what I was about to say.
What did I say it first?
2.0225 or just
No,
0.
mine doesn't work in the school balance because it's like a large.
So why do you think it doesn't matter that that number's awkward?
Because we're not going to use it.
What do you mean?
Because we can just do the thing that we learned how to do where you multiply where you square the dilation.
Well, sure, like that's the nitty gritty math of it, but at like a Photoshop, like why do you think the cost per square inch doesn't really like matter that
Because
much?
it's fractions of a cent.
Yeah, and is somebody going to print something that is just 1 square inch?
No.
Probably not.
Depends.
So
But
then,
you want just like to make that nice pixelated texture.
so then, Jake, you said the enlarged photo should just be times 4 of this if we're doubling it. So what is 45 cents times 4?
$1.80.
$1.80. So the principal shows up, Mr. Flynn, right? And okay, we don't have a vice principal, but the vice principal says my enlargement that I already ordered for the team costs $7.20. How big is his picture?
I would guess.
Divide by
But yeah. Just
yeah,
about
divide by 0.0225.
That might be harder than what we need to do.
4 times as big in both dimensions.
What did you do? What math did you do?
Well, 0.45 times 2 is 0.9 just because it's a nicer number. 0.9 goes into 7.2 8 times because basic multiplication. And then you multiply that by 2 because you multiplied by 2 earlier. And then that gives you,
That's a lot.
wait, no, that gives you 16.
Yeah, but if you square root it, it's 4 times bigger.
Wait, no, it gives you 18. Wait.
What?
Yeah, it gives you 18. I thought it gave you 16. It gives you 18. So it's the square root of it.
Okay, you lost me.
Yeah.
I believe it might help us if we write something down.
No,
I'm not even going to make you do it on paper.
I can write it on the board.
You
instead.
can write it on the board.
Okay.
You are perfectly allowed to
Do
just
it in
do
your
that.
best
I'm
handwriting.
not using any of these weird pens.
Wait, what are the other pens?
No.
They're the
No.
magic pen.
Paintbrush.
Just chill. Leave it be for now. Let's do the math, and
Can you
then
use
if
a
you want to
pen?
play with it, you can.
Yeah, they're using calligraphy
That's what I'm
pen.
using right now.
No,
Connor,
actually-
Akshay, it means like pick up a pen to write with, not use your finger, but it's up to you.
No. Okay. 0. Wait, that's a really bad position.
See,
4,
see,
5
okay.
times 2 equals 0.
No, wait, why are you doing that times 2?
Because it's an easier division in my brain.
Okay.
7.2 divided
No,
by.
it's 7.2 divided by 0.9.
Hey, Connor, would both ways work?
Technically, yeah.
Sure, but this one's easier.
Literally not.
So, if it's easier, that's all relative to you.
Okay.
Remember, we do not need to force
Oh,
our
it is
opinions on others. How we do math is all independent to ourselves,
Why
right?
did I think that was 9? Yeah, it's 4. Yeah. Okay.
Whoa.
It's just, I got it right the first time, and then you asked me to explain. What?
What?
Oh, 4 times bigger.
Oh.
In each dimension.
Now,
It's actually 16 times bigger.
Yeah.
well, what do you mean actually?
Wait,
What do you mean
dimensions of a photo
46?
is
So
16.
it's supposed to be a 16.
That looks nothing like a 16. Wait, why are we multiplying by 20? Oh, it's 20.
It's 16 by 20 because it's the dimensions
Got
of
it.
the photo.
So we all agree now.
Yeah.
The principal's picture that they got printed was 4 times the dimensions, which we said is 16 times larger if we're comparing areas.
No, 4 times larger.
No, 16 if you're comparing area.
Oh yeah, you're right. I'm stupid.
Well, you just didn't listen to the end of my sentence. Your brain was already trying to answer. This is something I'm going to push you guys to get better at.
No.
Answering questions.
Why?
No, actually listening to the person you're going to
I do
respond to.
that. It's just every-
Not just waiting to respond. Right? Because
Oh,
a lot of times, especially when we feel like we're smarter than the conversation, we don't wait to respond. So these, I believe we can do all these without much effort, so we're going to skip it.
Yeah.
I mean, unless you really want to do it. The only
No.
weird ones are like,
Please
No.
don't.
here you'd have to do a little bit of math because they give you the hypotenuse.
What was
30,
the
60, 90
question?
triangle.
Just to finish this
It's just a
table,
third for me.
this is just supporting our learning that the ratio of the areas is always going to be the length ratio squared. Cool? So as long as we're all cool with that, I'm cool to move on.
Unless you're moving into a three-dimensional shape. Then it
Which
would
we're
be-
not.
All right, then we're talking volume, though. Then what relationship would that have? Cubed, right?
And then four dimensions.
Oh.
All right, so Batia finds an online print shop that also makes enlargements, but because most of the rest of the world doesn't use this, I could use some
Oh yeah,
adjectives,
that's
but I should
way more expensive actually.
Imperial.
show me.
Oh,
Because
I don't believe you until
simple
you show
math,
me.
A square centimeter,
No, you're not.
a square centimeter is less than a square inch, and this is more than what it costs per square
no,
inch.
it's not, Jake. Last time, what it cost per square inch was 0.225.
0.0225. So it's
Okay, 0.2.
2.25 cents
Yeah.
per square inch, and this is 0.5 cents per square centimeter, and a centimeter is smaller than an inch, which means this costs more than this.
Your logic is flawed.
It's literally not.
Your logic is flawed because this is more expensive by square inch. So what is the conversion between an inch to a centimeter?
Mr.
Right there,
Hudson.
2.54.
Mr. Hudson. Okay, so
I
I'm just a
The
ghost.
thing is not too.
I appreciate you calling on me. I think we should have probably maybe written something down in the last slide.
Yeah, we should.
Maybe. So we said, well, not this last slide, this last slide.
Yeah, the important.
So we said this divided by 20
Really?
Is 0.0225.
is 0.0225, which is 2 1/4, we're arguing cents
per square inch.
per square
And
inch.
the other one is half a cent per square centimeter.
But how does a square centimeter relate to a square inch?
Yeah, that's
It's
smaller.
smaller.
Well,
But
okay,
how?
it's smaller doesn't. We need the actual ratio, Jake, because. Okay.
Because if Batia is not as smart as we are, we got to really defend it to her why she should or should not order from this shop.
Cents.
Label that. Please let's not leave numbers unlabeled at this point.
And then this is centimeters.
That looks like, I don't know, a sword?
It looks like a 4.
Oh, it does.
Five.
I can't unsee that now. It looks like a sword.
It does look like a sword too. I can't unsee that now.
Okay.
Sword.
You see this,
Okay,
Jake?
that's okay.
So if it's
That looks like a ring pop.
what is the what is the comparison between centimeters and
2.45.
okay.
Close.
Lily, what is down there?
2.54. You said it backwards.
That looks
Zero
like a sword.
point five
It looks like a ring
times 2.54 squared equals what?
Okay.
Hey
Wait.
Jake, you're now not helping the lesson. You are
Okay.
taking us backwards.
Okay.
Sorry, bud.
Right. Because
Time, place, and location. Well, place is
Yeah.
probably
See,
location.
Jake,
what is 2.54 squared? Someone with a calculator.
Wrist calculator thing.
Wait, it's gonna be over 4, right? Well,
equals 6.4516.
6.4516.
Yeah.
What is that?
Yeah.
It doesn't matter. All we need is half of it.
No, but what is what label? What the heck number do we have right
I'm
now?
so confused.
But that's how much
All right.
it costs per square inch.
We got to sit down
Wait.
now
Oh.
Wait.
because I got an I'm so confused. Not just an I'm confused, but I'm so confused.
The 0.
We're converting unit
That's
rates.
double how much it costs per square inch.
Wow, kazowie.
So
So, not very
whether or not you write this down is up to you. However, if we're comparing
Jake was
units
right.
I told you.
and we have one square
His
inch,
logic was flawed, but he was
logic is
Hey.
not flawed.
You could just like let it be that they were right and not try to double down on the like mild insult,
I could.
which
But
would
it's
be a better way to interact with your
But
fellow
it's fun to
humans.
screw people on.
But okay, can I?
cannot tell it.
What? Go ahead.
I
If we're
wanna
talking about the
I
math.
want to explain
I'm just tired of you guys telling each other that they're wrong.
Immediately say that it's bigger. Because Jake, if the conversion rate from a centimeter to a square inch was like, say, exactly 2 instead of 2.54, it would still be small. It would be cheaper.
Because it costs more for a smaller area. Because it costs more for the square centimeter than it did for the square inch.
No, it's
Neither of you are allowed to say anything else until you have paper and pencil out.
I have that.
I don't even care if anything's written on it yet, but you cannot continue. You cannot continue to just argue in words. I don't care if we argue. I especially don't care if we argue to try to get to the right answer of a problem that we need to solve. But there, you can't, like, it goes back to the logical fallacies that you should have learned in connections, but I don't know how good connections was last year because COVID and everything.
It was good.
You can't just keep repeating your argument. You have to have something.
Jake, here is my logic. It's a greater than equation. Here you go, Jake. My gift to you. Actually, it's a last man equation. My gift to you,
So
Jake.
you guys said that 1 inch squared equals. You had the number on the last slide, but then we didn't.
Oh, 0. Wait, we're talking in cents.
Well, I want the conversion because we're trying to figure out the conversion of this area.
6.4516.
Oh.
Centimeters.
So these are equivalent sizes. So we said at the one print shop that costs us.
Cooper Florence, please come to the main office. Cooper, please come to the main office.
Why? Oh, this dollar.
And at our other print shop, they told us
We should really
0.5.
be doing this in cents.
I mean, most of the world does not operate in cents.
They don't?
You just go ahead and put it in dollars. Like, you just use the decimal places.
Jake. Jake, right. That's 5 cents.
Hey, Connor. This is when you have to back yourself up a little bit. How much is the... Ooh, not that. How much is the cost at the new shop?
0.5 cents per square.
0.5 cents, right?
That's
So that's
what I'm saying.
half a penny. So if we try to write that down using the proper labeling, what, like, so this is 2 cents.
Oh, you're right.
Yeah.
What this comes down to is what? Place value, right? We are having a place value argument with each other. All we need to do, but you can't just keep repeating yourself, and you can't just call people stupid, right? Like, you have to defend what mistake they're making. 0.5 cents, which I disagree with working in cents, I think it's silly, but that's what they gave us, is actually what in dollars?
2
0.05.
0.
Yeah, I get it.
0.005?
Wait, no, is it 0.05?
So
Well,
Connor,
it's half a cent.
A cent is 100.
Half a cent. So 1 cent would be right here. So half a cent is in that next decimal place.
Got it.
Oh, it's mine.
so Connor could be right, but I could also be wrong.
Jake, you're right. I was just trying to point
I
out.
wasn't right. I
You can't jump to that conclusion.
Yeah, I know. I wasn't right because I didn't divide by 100. I divided by 10. Okay.
Yeah.
So if that is 1 centimeter squared, we're going to take the amount of centimeters squared, and if we want to work in dollars, times by 0.005. So what does that give us?
Substantially small number.
Yeah.
this is what I meant by we actually have to think a little bit in this lesson, don't we?
Yeah.
If you grab a calculator, point 0.032. I took the square centimeters. That equals a square inch because we just decided, okay, might as well compare. And then half a penny, half a cent, 0.005. So 0.032 is what would be the equivalent, right? Because these sizes, we said this, whether we're working in the square inches, which we figured out was 0.0225, or square centimeters, 0.032. So now we can compare them to each other. Who's cheaper? Which is who? The online or the local print shop?
Shop local.
Because you don't have to pay for shipping. You don't even need all the math for this equation. It's just like which one would be cheaper? Local print shop, online store. It's gonna be the local print shop.
So if I even wanted to take this and go the other way, we could convert the 1 inches squared into 1 centimeter squared. Right, 1 square centimeter.
We could do that.
Do we know what that conversion?
Is it 1 over that value? Or is that not right?
It's the same conversion factor, right? Just used differently. So 6.45. We have a couple extra decimals there. 6.45 is what they essentially say the area conversion between metric and American. If you're going inches to centimeters.
Wait, is the other way just like 1 centimeter over 6?
You either multiply or you divide. Yep. So if we're going the other way, we just do the other thing. So here we multiplied. If we want to do the other thing, we could divide. Does that make sense? Gotta watch out for your labels, your units, all that fun stuff. Here's a fun one. Do not jump to an answer too quickly.
The answer's 5.
Are these similar?
Wait, you said don't jump to an answer.
Yes. They are similar.
Quantum space.
They're similar.
Justify.
Okay, well,
Oh, yeah.
the side length's divided by 3 and the area is divided by 2.
All right, well, somebody from the no camp then justify your answer.
There's no one no longer in the no camp. We all do over the James camp.
My camp's just superior.
Yeah, they got a swimming pool.
Man, I think the second half of this year is going to be fun. Y'all are wrong.
Oh, what?
All 3 of you. And you're cocky about being wrong.
No,
I
I just
sorry.
said because
Well, Jake just said because our camp is superior.
I said there's a swimming pool.
How are they not similar, Mr. Hudson?
You tell me. That or prove me wrong.
Well, okay.
If you think I'm wrong, prove me wrong. What's it take to be similar? I don't disagree with anything that Jake said, but y'all are wrong.
Oh,
What?
they could be. Okay.
Say more.
We need
It
another
looked like
side.
your light bulb turned on.
You
You need what?
can't just have one side for similarity.
Oh,
Because all these angles could go wherever you want. You know?
Guys, this is why I start to get really worried about you taking those like big old test things that you have to, whether it's OST or ACT or OSTs for Ohio State tests, any of the things. We now, instead of, so I don't know if you guys remember when we called things like air tests or park tests or all these different like PARCC. It's all acronyms. The whole world is acronyms. Now we just say OST, so we don't have to worry about whatever the test is called. You have to slow yourselves down. I get it that we know a lot. No, you know a lot about a lot of things. But you have to go through the checklist when you're trying to say something definitively. Right? So already what we've seen today is multiple errors from trying to work too quickly and say just like, oh, well, I'm right, you're wrong. You guys gotta stop this. We gotta slow down and really think about these problems. So these could be similar. They're areas. compared to this length would support that they could be similar, but we absolutely do not have enough information here.
Then we have all the angles. Then we have all the angles.
All right, so we got a lot more pieces to this shape.
Are all rectangles similar? No.
No, but all squares are.
Triangles.
All squares are similar, and all circles are similar, but not all rectangles.
Okay. Yeah, Jake's right. I was like, cause you know how in a triangle you have all the angles.
Yep. So, I enlarge the figure at the right, nice little mountain range. So the area of the similar polygon is 900 square centimeters. What is the new perimeter?
Whatever the current one is times 3.
Yeah, whatever the current one is times 3. Just take your area,
Wait, 17
area scale factor, square it, or square root it in this case.
40.
And we go from there. So, I know some of us did not do the homework from Friday, and then I know we have today's homework. So let's go ahead and dive into that, because tomorrow then we switch gears, right? This is the end of this section, because tomorrow we start 841. So that's 8.3 was just a quick, like 8.3.1 and 8.3.2, was just a quick review in how like linear relationships versus area relationships have that relationship.
Yeah, we did.
You what?
We did really bad at it. We did really bad at it.
I can't tell if you're being facetious or not.
I don't know if it's facetious.
Sarcastic. All right, so I think we got everything recorded we need to. We might as well just pull out graph paper and do homework.